Welcome to Electrical and Computer Engineering, abbreviated as ECE. We will take a rapid tour of the department that highlights the activities of electrical and computer engineers. There are many research projects in ECE that involve faculty, undergraduate students, and graduate students. Many of these projects require contributions from the 7 specialties. In order to understand each of these specialties, we will examine a current project involving unmanned aerial vehicles, abbreviated UAV. This brief tour of ECE will show how each of the specialties contributes to the UAV project, and then I will describe a little bit about each area. The UAV used in our experiments is a helicopter that has been equipped with a computer control so that it can fly missions without a pilot. Typically, there is an operator that monitors the UAV from a ground station and then provides a mission for the UAV. An example mission would be to go to a location and then look at an object of interest. There is also a safety pilot that can take control and fly the UAV in the event of an emergency. An antenna is a device for sending or receiving information through electromagnetic waves. Devices such as cell phone, televisions, wireless routers, and Bluetooth all use antennas. The UAV has 3 antennas. First, the Global Position System, abbreviated GPS, is used by the UAV for navigation. Next, the safety pilot has a remote control unit that sends commands through an antenna to the throttle, main blade, and tail rotor to fly the helicopter. The UAV receives its mission commands via a wireless connection to a laptop computer on the ground. Electromagnetics is a term used to describe all aspects of antenna design and use. Theoretical questions center on how an antenna receives and transmits information. These questions can be answered through mathematical and computer modeling. The 2 graphics show computer simulations of antennas sending information. Testing of mathematical theories and computer models is done to verify the theories and models match the physical system. An engineer would ask questions such as, how can I measure the real antenna and compare it to the model? Specialized equipment is required to make these measurements. The picture shows measurements made on tire pressure monitoring systems. The range and quality of a wireless connection will rely heavily on the type of antenna used. The antenna must be designed based on the specific application. The picture on the left shows a low-frequency research antenna on top of the Flora Daniel building at Clemson. The antenna on the right shows the complexity of antenna design. Stored electrical energy in state-of-the-art lithium polymer batteries must be converted into mechanical energy in order for the helicopter to fly. The energy supplied by the batteries must be regulated to control the speed of the electric motors. Power system engineers design these types of systems. Study of power systems in ECE includes all aspects of power generation, storage, transmission, and use. On a small scale, devices such as cell phones and iPods require power systems. The same problems of power storage, generation, and use exist on a larger scale in systems such as electric vehicles. On a much larger scale, power systems engineers address the generation of electric power from fuels or alternative sources and the efficient distribution of the power. Efficient use of large motors and heaters is also studied. The UAV has a camera that can be used to measure or track objects on the ground or in the air. The image processing software takes ordinary video and automatically performs these functions. Image processing is a specialty within computer engineering that focuses on the processing of video to extract information. In these images, the image processing software has identified vehicles on the highway and a man walking across a field. An important use of image processing is to help robots navigate in the real world. We need to talk a little bit more about how the UAV flies automatically. Previously, we said it is actually controlled by an embedded computer. That is, at a lower level, the computer executes a mathematical algorithm in order to achieve flight control. Such algorithms are studied in the field of control systems. Engineers in this area develop models and algorithms that make systems such as robots operate. Control algorithms make systems that are normally unstable act in a predictable fashion. The Segway and rockets are systems in this category, since neither could function without a controller. An interesting question in control systems is, how do we make flying robots work together so that we could do something as travel in a flock the way birds do? The quad-rotor represents the same type of control system as that found in a big helicopter. The quad-rotor rolls and pitches by increasing the speed of one rotor compared to the others. The UAV requires a small, highly sophisticated electronic device to measure its position and orientation. This device measures orientation, acceleration, and rotational velocity. This information is then used to control the helicopter. Classical work in electronics centers on the design of devices such as computers, radios, cell phones, and printers. New types of sensors designed by electrical engineers have provided new products to consumers. Many of these devices are hybrids of mechanical and electronic components. These types of systems are often called micro-electromechanical systems. The wireless links are used to send information to and from the helicopter. This information must be packaged in such a manner that both sides understand how to interpret the information. Problems such as these are tackled by engineers specializing in the communications and networking focus. Important problems include compression and transmission of data streams such as that found in satellite TV. Secure communication of information is a very important topic in this area. How can you send information over the internet that can only be read by the intended receiver? Maximizing the sharing of limited communication resources is an important topic in communications and networking. In the depicted example, the goal is to maximize the number of cell phone users on a game day. Previously, we said that the helicopter flies by itself, but what we really mean is that there are onboard computers that read the sensors and change the pitch and the speed of the rotor blades automatically. This type of application is the same type of challenge faced in the software engineering group, as researchers try to reliably control systems such as the engine or the braking system in a car. Software engineering also addresses problems of computing and parallel processing. Questions such as, how can many computers work together to solve a weather simulation in 1 hour when it normally takes 100 hours? You have seen some of the activities in electrical and computer engineering and how these areas relate to an unmanned aerial vehicle application. If you have specific questions about the ECE department, please contact our undergraduate coordinator.